Hello everyone, I'm Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course Operating System. In this lecture, let us understand one more classical problem of synchronization, that is readers-writers problem. In our last lecture, we have understood in detail about producer-consumer problem, how it can be solved by using semaphores. So the same semaphores concept let us use today and understand how is this readers-writers problem can be solved. Before going into the solution, let us understand what actually this readers writers problem is. So readers writers problem means there is a shared file available and that shared file is shared between readers and writers. Reader is one process, writer is one process. Reader reads the data from that file and writer writes the data into that file. Reader can only read from that file, but whereas writers can perform both read and write operations onto that file. So quickly make a note of those 2 points. So there are 2 processes. First process is called as a reader, whose task is to read. This process can read the data from the file. And we have another process who is called as writer, can read and write the data. Into which? Into a shared file. So you will be having one shared file. Into that shared file, the data can be read by the reader and the data can be read and written by the writer. So reader and writer are 2 processes and these 2 are sharing this shared file. Now, what is the problem here? So the problem here is we have some scenarios to understand and we need to resolve those scenarios by giving the solution through semaphores concept. So what are those scenarios? Make a note of those scenarios, all of you. The problems are the first one is you can allow multiple readers to read the file simultaneously. Why? Because if you have a file, shared file, multiple readers can read the data from that file. There is no issue in that. So allow multiple readers to read the file simultaneously. That means read is possible. One simple example I am telling, 2 readers. RR stands for reader is possible. So I will make this one in the green color so that it will be, yeah, reader is possible. Second scenario, let us understand. Second scenario is when a reader process is reading or when a reader process is accessing a file, then a writer is not allowed to access that file. Why? Because if writer is writing the data and the simultaneously if reader is reading the data, there may be inconsistency in the data that is captured by the reader. So when a reader is accessing a file, then writer is not allowed to access the file. I hope you all are understanding. That means From this scenario, you need to understand when a reader is there, a writer is not allowed. So RW is not possible. Let us see one last scenario. Last scenario is when writer is accessing the file at the same time, any other process is not allowed to, like any other reader or any other writer is not allowed to access the file, right? So when a writer is accessing the file, then a reader or a writer, that means both the two writers can't be given access to a file. Why? Because if both are writing at one time, there may be chance like they may overwrite the data. Also, if a writer is writing at the same time, reader is not allowed to read the data. They may get an inconsistent data, right? So when a writer is writing or when a writer is accessing the file, then a reader or writer, both, is not allowed to access the file. That means WR and WW not possible. I hope these three scenarios or these three problems are clear to you or as part of readers writers problem when they are accessing the shared file. What is that? Shared file, if it is provided, then multiple readers can read the data simultaneously. But if a reader is accessing the file, at that case, writer is not allowed to write the data into that file. Also, if writer is accessing the file, at that time, reader or another writer is not allowed to access the file. So we need to give a solution to the reader and writer which satisfies all these three requirements using the semaphores concept. Using semaphores means in the last lecture we have understood in detail about semaphores. Semaphore is an integer variable which can be accessed only by two operations that are wait and signal. For your understanding, I'll write what is wait and what is signal here. So wait will take that semaphore variable and what it does, it will check if while this S value, whatever you are taking is less than or equal to 0, it does nothing. If the S value is greater than 0, then it will simply decrement the value of that variable, that semaphore. Similarly, the signal function is like this. Signal will take that semaphore variable and what it does, it will simply increment the value of S by 1. That's it. So these are the two functions we have already learned in detail in our last video, where signal and wait functions can be accessed by the semaphores. Alright. Now to give the solution to the writer's problem, what kind of variables they are using, let us make a note of that one and then we will understand the logic behind the reader's code snippet and the writer's code snippet. Okay. So the variables that they are will using, the shared data that they will be using are the first shared data they will be using is first one is obviously a shared file is required and second one is an integer variable which is named as a read count, which is an integer variable. Now what is the use of this read count is it will help us how many read processes are accessing that file, just to know how many readers are there Okay, how many read processes are there which are accessing that file? Okay, how many read processes are accessing the file? To know that, we will be using this read count. Next one is we will be using two semaphores here. The first semaphore is mutex, which will be initialized to 1. That means initial value of mutex equal to 1. This will help us to protect the read count. While understanding the logic, you will understand what is the use of this mutex. Just make a note. This mutex variable, which is a semaphore, it is a binary semaphore whose value can be 0 or 1. Okay. And it is helping us to protect the read count variable. Second semaphore we will be using is WRT, which is also initialized to 1. And it is also used to protect shared file. So how they are going to do that? While learning the logic, you will be understanding that one. So these are the three things that we are using: shared file, read count, and two semaphores that are mutex and WRT. So with this background knowledge, let us understand how the solution has been designed which solves these three problems, which has to achieve these three problems using semaphores. So first, let us have a note of writer's problem. Writer process, what is the logic the writer has to go through before using the shared variable, that is our shared file. We will see that one. So writer has to execute the code like this, where this is the writer's logic, where writer, before writing into the file, he has to run this wait method where the WRT variable value will be passed. And after writing into the file, this is the exit section where signal has to be executed with this WRT semaphore variable. Alright, let us make a note of this reader's process also, and then we will see how it is working. Reader process I'll write here. So this is the code snippet that has to be followed by the reader. We will understand what is this. What is this? So just to have this in an organized way, I'm just aligning them. So where this read performance is the critical section. Okay. All right. So let us understand how this process is working. Okay, so we will have multiple scenarios. Let us see the first scenario. Our first scenario is two readers, or let us see the first scenario where two readers are allowed to write this one. Two readers are allowed, right? So we will see this first scenario where two readers are allowed. So to reader means this logic we have to execute, right? So let us execute that logic and we will see whether we could able to solve this one. So let us consider the first reader R1, the reader R1. Okay. Now what happens? Reader R1 will enter into this one and R1 is executing this one. Weight of mutex. So first what we will do, we will take all our variables. What are they? Read count is required. So read count. Initially, the read count value is equal to 0 and then the mutex value is equal to 1 and then WRT value is equal to 1. Okay, so these are the initial values. All right, now R1 wants to read the data from the file, but directly it can't be allowed to enter into the reading the file. So what it has to do, it has to execute this complete entry section. So this is your entry section. It has to go through the entry section and then it has to go to the critical section. So first it will execute weight of mutex. What is weight of mutex? Mutex value is 1. Weight of mutex means the mutex value will be compared here, which is 1 in this case. 1 is less than or equal to 0. Right. 1 is less than or equal to 0. So the condition has become false. When the condition has become false, it will come here and it will decrement that semaphore, which is mutex in this case, value by 1. So now what happens? This value will be now 0. Got it? After this statement is executed, it will come back here and it will go to the next statement. What is the next statement? Read count will be incremented by 1. So the read count has been incremented by 1. After this, it will go here. If read count equal to 1, yes, read count is equal to 1. So what happened? It has to execute the weight WRT. What is WRT value? 1. So weight of 1 we are passing. 1 is less than or equal to 0, which is false. So it will reduce the semaphore value. What semaphore value? WRT we are calling. So its value will be reduced by 1. So the value has been reduced to 0. After executing this one, it will come back here. After double weight WRT, it is a if statement. Only once it will be executed, it will come here and then it will execute signal mutex. What is signal mutex? Mutex value is 0 and that with that 0 value will be sent here. Signal, what it does, it will increment that semaphore variable. What is that semaphore here? Mutex. This 0 will be incremented by 1. Okay, and then now R1 is reading the process. So R1 has entered into the critical section. This is our critical section. So it is performing the reading operation. Now while R1 is reading the operation, let us see if R2 wants to enter into the critical section, whether we are blocking it. No, we should not block. Why? Because two reads can be possible. Right. So R2 is now starting with this one. It is executing weight of mutex. What is mutex value? 1. Weight of mutex means it will go here. 1 value is less than or equal to 0 because mutex value is 1. 1 value is less than or equal to 0 is false. Its value will be reduced. So now this weightax value will be reduced to 0. Now R2 will go to the next statement. Read count will be incremented by 1. So this value will be now changing to 2. Now read count is equal to 1. No, read count is 2. 2 is equal to 1 is not false. So it will skip this statement. It will go to the next statement. What it does, signal of mutex. What is signal of mutex? Signal of mutex is mutex value is 0. So signal of mutex means that mutex value will be incremented by 1. So 0 will now change to 1. Now R2 can also enter into the critical section and it could able to perform the read operation. So we could able to satisfy this condition. What is that? Two read operations are possible. I hope you all are clear till now. Right? Okay. Now we will see the next one. Let us consider R1 and R2 both are performing this operation. Okay. Now let us see whether we could able to act the writer operation wants to read the critical section, whether it could be able to perform that operation or not, we will see. Okay. So let us consider writer wants to perform the operation. No, writer. This is not visible. Okay. Writer wants to perform the operation. W1, writer 1. What it does, it will go inside this operation. It is executing weight of WRT. What is WRT? 0. Weight of WRT means weight function will be called WRT value is 0. 0 is less than or equal to 0? Yes, it is true. Now what happened here? Our writer is in the loop because when the condition is true, here the with WRT we are calling, right? With WRT we are calling means what happened? It is less than or equal to 0, which is equal to 0, which is true because the condition has become true. What happens? The writer will be waiting here continuously. Once the condition becomes false, then only it will go to the next statement, isn't it or not? So here what happened? The writer has been blocked here. So there is no chance like it can enter into the critical section. This is the critical section here. There is no chance for writer to enter into the critical section when reader is performing this. It's a reading operation. So we could successfully able to achieve the second condition also, which is when reader is doing the operation, writer is not allowed to enter into the critical section. I hope you all are could able to understand the first two cases. When reader is doing, another reader is allowed. But when reader is doing, writer has been blocked here. I hope you all could able to understand. Right. Now let us understand the third scenario. So to understand this one, let me erase all these things first. We will start from the beginning because when the writer is and has got the chance to enter into the critical section, whether a reader or another writer is been blocked or not, we will see. Okay, that we will see now. So let me erase all these things so that it will be clear to you all. All right. So first scenario what we will take, let us consider the writer has requested first. The writer wants to write something into the file. So let us take one writer. So what we will do, we will take one writer. W1 is the writer. Okay. Now whenever writer wants to enter into the critical section, it will go here. Before that, what we will do, let us initialize the values. Read count is equal to 0 initially. Mutex value is 1 initially, and then WRT variable, which is a semaphore, is also 1. Okay. Now, writer wants to enter into the critical section. Before entering into the critical section, it has to execute this statement. What is that? Weight of WRT. Weight of WRT is what? WRT value is 1. It will go here. 1 is less than or equal to 0 is false. So what it does, the WRT semaphore value will be decremented by 1. So this value is now 0. After executing this statement, it will come here and writer is allowed to enter into the critical section. Now writer is in the critical section. Now while writer is in the critical section, let us see if another writer wants to enter into the critical section. In that case, W2, whether it is allowed into the critical section or not, let us see. Now what happens? W2 will start executing weight of WRT. Weight of WRT is 0. So 0 is less than or equal to 0 is true. So it has been blocked here. When the condition is true, it will not be coming out of this one. It will be continuously checking that one until the condition becomes false. When the condition becomes false, then only it can come here, right? So now W2 has been blocked here. It is not allowed to enter into the critical section. So we could able to successfully achieve this one. What is that? Two writers are not allowed to access the mm, file at a time. Okay. Now W1 is already in the critical section. Let us take another resource, that is R1 wants to enter into one reader wants to enter into the critical section, whether it is possible or not. Okay. Now when the R1 wants to enter into the critical section, already W1 is in the critical section. Okay. R1 starts its execution. It is executing weight of mutex. Mutex value is 1. 1 is less than or equal to 0 is false. So its value will be decremented by 1. So its value will be 0 now. After executing this statement, it will come here and it will start. Read count will be incremented by 1. So its value will be incremented by 1. It will come here. If read count equal to 1. Yes, 1 is equal to 1, which is true. It will come here. Weight of WRT. What is WRT value? 0. It will come here. Okay. Wait, WRT 0. 0 is less than or equal to 0, which is true. Now here R1 has been blocked because the condition has become true, and once the condition becomes false, then only it can go to the next statement, right? So 0 is less than or equal to 0. WRT value is 0. 0 is less than or equal to 0. So that's why the reader has been blocked here. So it is not allowed to enter into the critical section. So we could able to successfully achieve when a writer is already there in the critical section, the reader has been blocked. So all these statements are successfully achieved. I hope you all are clear with how two readers are possible, how a reader, if it is there, writer has been blocked, and how when a writer is there, another reader or a writer is also blocked. Right. One more scenario you understood here. When a writer, let us consider the writer got a chance to enter into the critical section. Okay. After entering into the critical section, after its work is done, it has to go through all these statements, which are called exit section, which will help another writer to enter into the critical section. Why? Because two readers can go. But once a reader work is done, to allow the other writer to enter into the critical section, these lines of code will help us in achieving that one. As of now, we have learned multiple ways of tracing this one. I will leave this part just to check once a reader has come whether writer could able to enter into the critical section or not after executing this statement. Just trace this one and understand. I hope today's lecture is clear to you all, where we could able to solve this readers writers problem in detail using the semaphores concept by using two semaphores and a variable. With this, we come to an end of today's lecture. In the next lecture, we will understand the third problem, which is dining philosopher's problem. Let us all meet in the next lecture. Until then, thank you all of you.